So let's start our session. Okay. So first I will introduce some theory part. Then we will go to the previous year questions. So simply, what is an eigenvalue and eigenvector? Okay. In order to understand that, we just need to know this equation, that is Ax equal to lambda x, where in this A is a matrix and its eigenvector is nothing but x here. Okay. When we multiply a matrix with its eigenvector, then it is written as lambda into x. That is this same vector. Okay. So when we multiply a vector to a matrix and we are getting that same vector in a scaled format. Okay. That is lambda into x. If we get like this, then this x is nothing but eigenvector of matrix A. And here lambda is nothing but eigen value. Okay, this is the first thing we need to understand in case of eigenvalues and eigenvectors. Okay, ax equal to lambda x, this can be written as ax minus lambda x equal to 0. Also, when we take x as common, we can write like a minus lambda I into x equal to 0. Okay, if you uh, know what is a homogeneous system of equation, in the previous session we have discussed what is homogeneous system of linear equation while studying the solution of system of linear equation. Okay, so this is a in the format of homogeneous system of linear equation, and this can be rewritten as like this whole thing can be rewritten as a dash, so we can write like a dash x equal to 0. This is like a homogeneous system of linear equation. So in order to have a non-trivial solution to a homogeneous equation, we have to it has to follow a condition, that is determinant of a minus lambda I must be equal to 0. Okay, to have a non-trivial solution, this has to be 0. The solution to this equation is called eigenvalues. Okay, so just remember these two things. Okay, the first thing is nothing but in case of eigenvector or eigenvalue, first we need to remember the equation ax equal to lambda x. Then next thing we need to remember is that a minus lambda I, its determinant should be equal to 0. And by solving this equation, we will get value of lambda as lambda 1, lambda 2 up to lambda n. Okay. If the order is n here, if A is an n by n matrix, we will be getting n number of eigenvalues. Okay, so if order is 3, we will be getting 3 eigenvalues. Okay, sometimes we get same value twice, like 1 0 0. Then we can write eigenvalues are 1 0, but effectively actually for a 3 by 3 matrix we have 3 eigenvalues. Okay, so by solving this we will be getting eigenvalues. Now let's take an example, like let's take a is equal to, let's take a is equal to 1 2 3 0 2 3 and 0 0 5. Let's take a simple example here. We need to find the eigenvalues and eigenvectors for this matrix A. So first we have to find eigenvalues here. Okay, so for that, a minus lambda I determinant equal to 0. So what is a minus lambda I? Okay, this is a. Okay, what is lambda I? Lambda I is nothing but the identity matrix multiplied with the, or the unit matrix multiplied with the lambda, that is lambda 0 0 0 lambda 0 0 0 lambda. Okay, so determinant a minus lambda I can be written as determinant of 1 minus lambda 2 3, then 0 2 minus lambda, then 3 0 0 5 minus lambda, which is equal to 0. By solving this equation, okay, by solving this equation, we will be getting the values for lambda. That is called eigen values. Okay, we can find that. Okay, so okay, so just calculating this, like calculate the determinant, that is 1 minus lambda into 2 minus lambda into 5 minus lambda minus 0 equal to 0. So this can be written as 1 minus lambda into 2 minus lambda into 5 minus lambda equal to 0. So this equation, okay, this equation is called characteristic equation. Okay, by solving this characteristic equation, we will be getting the values for lambda. Okay, this is called eigenvalues of this matrix. Okay, so what is the value of lambda here? Since this 1 minus lambda into 2 minus lambda into 5 minus lambda equal to 0, we can write 1 minus lambda equal to 0. This is one solution. Okay, so lambda equal to 1 is a solution. Similarly, lambda equal to 2 is a solution, and lambda equal to 5 is a solution. So for this 3 by 3 matrix, we got three values. These are the eigenvalues of the given matrix. Now for each of these eigenvalues, we can find eigenvectors. Okay, so we can write, in order to find eigenvector, we can write equation like ax equal to lambda x here. Okay, so for first case, we are taking the value of lambda as this one here. Okay, lambda equal to 1, this we are taking first. So only I'm doing one example here. Later uh, values are not going to discuss here, just one example is discussed here. Okay, so ax equal to x, then we can write like, okay, we can write like this. Now calculate this part. Okay, a is, this is a, right? A minus I, that is I'm calculating here 1 0 0 0 1 0 0 0 1. Okay, so if I do this, I will be getting 0 2 3 0 1 3, then 0 0 4. Okay, this is the resultant matrix A minus I. Okay, so x can be written as something like xyz. Okay, then equal to 0. So from this we can write equations such as multiplying this we will be getting 0 into x plus 2 into y plus 3 into z equal to 0. So the next equation is 0 into x plus y plus 3z equal to 0. And third equation is 0x plus 0y plus 4z equal to 0. Okay. So we need to solve these three equations. Okay. Solve these three equations to find the eigenvectors here. Okay. Okay. So from this third equation, we can write like z equal to 0. Okay. Now from the second equation, I can write y plus 3z equal to 0. So from this, I will be getting y equal to 0. And by substituting y and z, I will be getting x equal to 0 from the first equation. Okay. So the eigenvector for this lambda equal to 1 is nothing but 0, 0, 0. Okay. So this is the eigenvector I got for the eigenvalue lambda equal to 1. So for other values, you can calculate the eigenvectors. Okay. So this is how we have to find eigenvalues and eigenvectors. For explaining that part, I have discussed this far. Now, the important uh, concepts or points to be noted for the GATE exam is the properties of these eigenvalues and eigenvectors. Okay, so we will be now discussing the properties of eigenvalues. Okay, properties of eigenvalues. Okay, so just looking at the chat. Okay, so I'll be discussing the properties of eigenvalues here. First property is that the eigenvalues of matrix A and A transpose are the same. Okay, this is the first property. If I take a matrix A and find its eigenvalues, the eigenvalues of A transpose also remains the same. This is the first property you have to remember. Then eigenvalues of triangular matrix is its leading diagonal elements. Okay. If we consider a triangular matrix, then its leading diagonal elements are nothing but its eigenvalues. Okay. In the example we have discussed here, okay. In this example, I have considered this example. This is the matrix A here. Okay. This is a upper triangular matrix. You can see like the below the leading diagonal, we are getting all zeros. So this is an upper triangular matrix. Sorry, not this one. This Okay, this was the original matrix A. Okay, this was the original matrix A. So this is a upper triangular matrix here. Okay, so its eigenvalues are nothing but its diagonal elements 1 2 5. Okay, in the previous example, after finding equating the determinant to 0, we got lambda equal to 1 2 5, which is nothing but the diagonal elements here 1 2 5. Okay, so that's the second property here. Okay, eigenvalues of a triangular matrix is its leading diagonal elements. Okay, this is the second property one has to remember. Okay, now third property is, let A be an idempotent idempotent matrix, that is A square equal to A. If this is true, then the eigenvalues lambda is equal to 0 or 1. Okay, this is the property of eigenvalues related to idempotent matrix, that is A square equal to A. When A square equal to A or A is an idempotent matrix, we can have eigenvalues 0 or 1. This is the third property. Then fourth property, fourth and fifth is very important, which is uh, used to solve the eigenvalue problems very fast. Okay, so this fourth and fifth property is very important. So sum of eigenvalues of a matrix A is sum of its diagonal elements. Okay, like let's say A1 B1 C1, A2 B2 C2, A3 B3 C3 is matrix A. Okay, let lambda 1, lambda 2, lambda 3 be the eigenvalues of this matrix. Then lambda 1 plus lambda 2 plus lambda 3 is equal to A1 plus B2 plus C3. Okay, so the sum of eigenvalues is equal to sum of its diagonal elements A1, B2 and C3. Okay, now we are going to discuss fifth property. This is also very important property. Okay, so the fourth and fifth one is very important. Lot of questions are designed based on this fourth and fifth property. So fifth property is, the product of eigenvalues of a matrix matrix A is equal to determinant of A. Okay, in the previous example, let's say we have considered this matrix A and its eigenvalues are lambda 1, lambda 2, lambda 3. Then according to this fifth property, we can write like determinant of A is equal to lambda 1, lambda 2, lambda 3. Okay, this is the fifth property you have to remember. Okay, Then sixth property. If lambda is an eigen value of matrix A, then 1 by lambda is an eigen value of matrix A inverse. Okay. So this is also important. If lambda is an eigen value of matrix A, then 1 by lambda is an eigen value of matrix A inverse. This is the sixth property. Okay. Seventh property. If lambda is an eigen value of an orthogonal matrix, then 1 by lambda is also an eigen value. Okay. So for an orthogonal matrix, if lambda is an eigenvalue, then 1 by lambda is also an eigenvalue. Why? We know in orthogonal A into A transpose equal to I. Okay. Or we can say A inverse equal to A transpose in case of orthogonal matrix. Okay. So if A is having lambda, then A inverse is having 1 by lambda according to the previous property. Okay. So we can say when lambda is an eigen value of an orthogonal matrix, then 1 by lambda is also an eigen value. Okay. Now let me discuss eighth point here. Okay. Let's say let's lambda 1, lambda 2 up to lambda n be eigenvalues of matrix A. Then lambda 1 raised to n, lambda 2 raised to n up to lambda n raised to n is eigen values of matrix A raised to n. Okay. This is also in exam point of view, some questions are asked based on this. If a matrix A is having eigenvalues lambda 1, lambda 2 up to lambda n, then the vector A raised to n will be having the eigenvalues lambda 1 raised to n, lambda 2 raised to n up to lambda n raised to n. So these are all the important properties we have to remember for solving eigenvalue or eigenvector problems. Okay. So we will be jumping into the previous year gate questions here. Okay. So this is the first question. Okay. So anyone in chat can answer. So this is the first question. The eigenvalues of matrix A1, A1 are. Okay. We have to calculate the eigenvalues of matrix. So for this, we will be using some properties of the eigenvalues of a matrix. So here, let me assume lambda 1, lambda 2 be the eigenvalues of this matrix since it is in the order of 2 by 2 matrix. So these are the assumed eigenvalues. Then, according to the properties of eigenvectors, we know that lambda 1 plus lambda 2 equal to sum of its diagonal elements, that is a plus 1, a plus 1. Now, what is the product of this eigenvalues lambda 1, lambda 2? Which is nothing but the determinant of this vector a1, a1. Okay. Since the two rows are same, we can say the determinant equal to 0 here. So, which of these options satisfy this equation and this equation? Okay. Let me first check option A here. Okay. In A, let me take a plus 1 as lambda 1 and 0 as lambda 2. Okay, then lambda 1 plus lambda 2, we are calculating this a plus 1 plus 0 which is equal to a plus 1, so which satisfies this equation. Now a plus 1 into 0. Okay, when we do this, we will be getting 0 here. So it satisfies this equation also. So since it is satisfying both this equation, let me check all other options here. Okay, a plus 0 is not equal to a plus 1. So this is not true. A minus 1 plus 0 is not equal to a plus 1. So this is not also true. Then 0 plus 0 is not equal to a plus 1. So this is also false. So the correct answer is option A here. So for this question, the correct answer is option A plus 1 comma 0. So I am moving on to next question here. Okay. So this is the next question. Just try to solve by yourself. So for the following matrix, okay, a matrix is given 1 minus 1, 2, 3. The number of positive characteristic roots is, okay, what is characteristic roots here? It is nothing but the eigenvalues here. Okay. So in order to solve this, we have to find determinant of a minus lambda I equal to 0. This is the characteristic equation of this matrix. Okay. So if I do this, I will be getting 1 minus lambda here, minus 1, 2, then 3 minus lambda here, which is equal to 0. So 1 minus lambda into 3 minus lambda plus 2 equal to 0. By expanding, I'll be getting 3 minus lambda minus 3 lambda plus lambda square plus 2 equal to 0. This can be written as lambda square then minus 4 lambda plus 5 equal to 0. Okay. Now just try to solve this using the equation lambda equal to like minus b plus or minus root b square minus 4 that formula. Okay, solving quadratic equation. So 4 plus or minus root b square is 16 minus 4ac is 20 divided by 2. Okay, so when we look at here, this is 16 minus 20, so it's a negative inside a root, so I'll be getting some imaginary numbers here. Okay, so the question is asking number of positive characteristic root. Okay, so the options are 1, 2, 4 and cannot be found. Since I'm getting complex number as a root, I can say there is no positive characteristic root for this equation. So the correct answer is option D here. So the correct answer to the question is option D here. Okay, getting all of you got the correct answer. So moving on to next question here. Okay, just try yourself. Very simple question. When we look at each subtopic, it feels simple. So find the eigenvalues of this matrix. Okay, just let me check the chat. Okay, so here it's a 3 by 3 matrix, right? This is a 3 by 3 matrix. So let's assume the eigenvalues are lambda 1, lambda 2 and lambda 3. Okay, these are the eigenvalues. Let's assume that. Now we can write lambda 1 plus lambda 2 plus lambda 3. That is the sum of eigenvalues equal to sum of diagonal elements. That is 1 plus 1 plus 1, which is nothing but 3 here. Then lambda 1, lambda 2, lambda 3. Okay, which is nothing but the determinant of this matrix. Let me say this is matrix A. Then determinant of matrix A is the product of eigenvalues. So here all the rows are equal. Okay, at least when at least two rows are equal, the determinant is 0. So which is equal to 0. So we need to satisfy these two equations, equation 1 and 2. Now look at the options here. Which three eigenvalues add to give 3 here? Okay, this is not correct. It is giving 0 as the sum. This is giving 1 as the sum. So this is also not the answer. And option C, we can see 0 zeros plus 3, which is 3. So this equation 1 is satisfied here. And in option D also 1 plus 1 plus 1, which is equal to 3. In option C and D, this equation 1 is satisfied. Now look at the equation 2. Okay, lambda 1 into lambda 2 into lambda 3. Okay, 0 into 0 into 3 is 0. 1 into 1 into 1 equal to 1. So considering option C and D, equation C satisfies the equation 2. So only one option satisfies both equation 1 and 2, that is option C here. So our answer to this question is nothing but option C here. Okay. So this is the correct answer to the question. Now we are moving into next question here. Fourth question. Okay. Just try yourself to solve. What is the question here? If the vector 1, 2, minus 1 is eigenvector of this vector, okay, eigenvector of this matrix, then one of the eigenvalues of A is, okay, so this is A here, okay, this is A here, this is given as one of the eigenvectors, then find one of the eigenvalues. Okay, so since we the one eigenvector is given, we need to apply the equation of eigenvector Ax equal to lambda x. Okay, This is the equation of eigenvector. So here A is given, like this is A here, and one of the eigenvector is given. So just multiply. So we will be getting one eigen value, and let us check whether that is in our option. So this is A here, X here. Okay. When we multiply these two, we will be getting minus 2 plus 4 plus 3. Then second row is 2 plus 2 plus 6. Then third row is minus 1 minus 4 plus 0. Okay. Now simplify this. We will be getting the first row is minus 2 plus 4 plus 3 is nothing but 2 plus 3, that is 5 here. Then 2 plus 2 plus 6, 10 here. Then minus 1 plus minus 4, that is minus 5 here. Okay. Minus 5 here. Okay. Since this is already given as an eigenvector, we can take like 5 common here. Okay. When we take 5 common here, this can be written as, if I take 5 common here, this 5 becomes 1, this 10 becomes 2, and this minus 5 become minus 1. Okay. So now this is in this format, like ax equal to lambda x format. Okay. Here this is x here. So this is the x here. So correspondingly, this is lambda corresponding to this eigenvector. Okay. Since this lambda is available in option, okay, 5, the question is, then one of the eigenvalues of A is, okay, then we can definitely say 5 is a eigenvalue of matrix A. So the correct answer to the question is option C, 5. Okay. So I think all of you got the answer. So I'm moving on to next question, fifth question here. Okay. Let me check the chat here. Okay. Okay. Which of the following is a eigenvector of the matrix? Okay, the question is not complete here. Okay. I'll be complete the question first. Option A is 1 minus 2 0 0. 1 minus 2 0 0. Option B is 0 0 1 0. 0 0 1 0. Option C is 1 0 0 minus 2. 0 0 minus 2. Then option D is 1 minus 1 2 1. 1 minus 1 2 2. Transfer. Okay. This is the correct options. Okay. So the question is find which of the following is an eigenvector of the matrix. Okay. So in order to find that, when we multiply a matrix A, let me say this is matrix A, we can say for an eigenvector x, we can write like Ax equal to lambda x. So just multiply A with the given options here. Okay. So that's the easy method here. So this is the matrix A here. Then let me just multiply with the option A first. Okay. Option A is 1 minus 2 0 0. Okay. If I multiply this, I'll be getting the first element will be 5 here. Next minus 10 here. Then 0 here and 0 here. Here from this column matrix, I can take 5 out. So 5 into 1 minus 2 0 0. So this is in what format? Okay. This is in the format Ax equal to lambda x. Okay. This is A, this is x, and this is lambda, and this is again x. Okay. So Ax equal to lambda x format here. And here 5 is the eigenvalue here. So when I multiply with the first option itself, I am getting the Ax equal to lambda x format. So since I am getting in this format, I can say that x is a eigenvector of the matrix A. So in this example, I have tested this condition, option A here. Okay. When I multiply this vector, I am getting a scaled version of that same vector. So I can say this vector is a eigenvector of matrix A. So the option A is the correct answer here. Okay. From the first option itself, we are getting the correct answer. Okay. So I'm moving on to the final question here. Today's final question. So this one you can quickly answer. So just do yourself. Okay. So what is the correct answer? Eigenvalues of a matrix S. Okay, a matrix S is given 3 2 2 3, and its eigenvalues are given as 5 and 1. Then what are the eigenvalues of the matrix S square? Okay, this is directly from the property of eigenvalues here. Okay, so according to the property of eigenvalues, when lambda 1, lambda 1, lambda 2 up to lambda n is eigenvalues of matrix A, then lambda 1 raised to n, lambda 2 raised to n up to lambda n raised to n is the eigenvalues of the matrix A raised to n. So here instead of A raised to n, we have given S square here. So eigenvalues of the given question 5 and 1 for S. Now for S square, what are the eigenvalues? It's nothing but 5 square comma 1 square. That is 25, and 1 is the correct answer. Okay. So from the first option, okay, option A, it is given as 1 and 25. So the correct answer to the question is option A, 1 and 25. Okay. So some important questions or commonly asked pattern questions in the subtopic eigenvalues and eigenvectors are discussed here. I think you all got the idea of eigenvectors and eigenvalue problems which asked in previous year questions here. So thank you for watching this live session. Okay, so we will be meeting in the next session probably tomorrow. So do subscribe and support channel. So thank you for watching this video. Good day to all. Bye. Okay, bye.